Hello, this is Mr. Huff. In this video, we are going to calculate using the spreadsheet the moment of inertia and the elasticity. From a previous video, we found that we have some values here. 48.6 pounds was our force at the yield point, and it deflected 0.01442, and we had an ultimate yield strength of 49.997. So one of the things you'll want to make sure is that when you're entering this, that you're putting the values on the right row for that sample. And I'll have more information in this when you get your hands on it, but for now this is how to enter the calculations. That's something I want you to do. So remember our formulas. That the moment of inertia is equal to the base times the height cubed divided by 12, and elasticity is the force times the length raised to the third power divided by 48 times the deflection. In the formulas in class we've been using delta max, but I'm using D here for deflection, and I is the moment of inertia. So let's go back to our spreadsheet here. So here we have the base and the height of our sample, and I put in some fake numbers here so we could see how this works when you copy it down. But I'm going to start a formula here in this zone. If you watch in this box right here, you'll see the formula show up. So equals, and I'm going to open a parenthesis. I'm going to click on the base for that row, asterisk to multiply, and then the height is in column G, so I'll click that. And I'm going to use a grave and a 3 to raise it to the third power. Close the parenthesis, divide by, and 12. Alright, so there is my calculation. It's going to ask if I want to autofill. Click check, and it will fill it all the way down to the bottom. So here are all my moment of inertias. And I have some fake numbers here, so you'll see a lot of crazy things. Okay. Just for the sake of this video, I'm going to copy these down because this is fake data. Let's see. I'm going to highlight the stuff I want to copy and just copy that down a few because I want to show you the modulus of elasticity calculation now. So we're going to press equal, and it's the force. The force is the yield point force, 48.6 in this example, times the length, and that is right here in column H, raise the length to the third power, divide by, open a parenthesis, and 48, times the deflection, times the moment of inertia that we just calculated here. So all I'm doing is just clicking on the things in that row that I want to insert into that formula. So I have the force times the length cubed divided by 48 times the deflection times the moment of inertia, close the parenthesis, enter. And it did not ask if I wanted to fill that down this time. So if you see this little blue square, left click on that and drag down, and it will fill that value down. Okay, and in this case I've got a bunch of different bases and heights, and I use the same value for everything here. You are going to collect for each sample the yield, the deflection, and the ultimate strength. What this is going to let you do is it's going to let you to compare the different kinds of materials and make some statements based on your analysis. So that's enough on this. Really what we did is we learned how to calculate using a formula the moment of inertia and elasticity, and how to copy that formula down so that as you change this data, let's say that these were my actual things here, those calculations are changing as you put in new numbers. So you can see that that changes when you change this. Okay, so that's all you need for this video. Thank you for watching.